Bismillah, Alhamdulillah, wassalatu wassalam ala Rasulillah. This is Team 2, and today we're gonna represent the equipment overview topic. Okay, let's start with introducing the team. This is Abdullah Warsama speaking to you. Mohammed Bukhari is the motivator, Ahmed Harbi, organizer, Mohammed Khudri is the team leader, and Khalid Abdin as a recorder. The topics we're gonna cover today include the motor and turbine and engine configurations, pumps and mechanical fans, compressors and gearboxes. Then we're gonna move to the coupling as well as the bearing. Then we're gonna conclude our presentation. Rotating equipments can be classified into three main categories, such as driver components like motors and turbine and engines. Then we're gonna move to talk about the driven components such as pumps, fans, compressors, and rolls. There are intermediate components between the driver and driven, such as coupling and gearboxes. Okay, before we go to the motor configuration, it is very important to distinguish between the generators and motors. Generators basically convert mechanical energy into electrical energy. I'm quite sure you guys are familiar with this picture when you go to the camping, and usually people use this to generate electricity. Another thing is motors. Motors basically convert electrical energy, takes the electrical energy as an input, then convert it into mechanical energy for rotating machineries. Electrical motors can be classified into two components, AC motor and DC motor. AC motor basically is the alternating current motors, such as this one in this graph. As you can see, the current is going up and down, while the DC motor, it just goes straight without alternating. There are two types of AC motors, single phase or three phase. Single phase is just basically one line of these three, and three phases are, as you see here in this plot, have three lines, goes with an angle between them, phase angle between each one, which equal to 120. There are another type also, which is called the induction. Induction can be classified into squirrel cage or wound rotor. On the other hand, we have DC motors have three main categories. Actually, it's classified based on the electrical circuit. If it's connected in a series, so it's called series one, and if it's parallel, so it's called shunt wound, or it's maybe can be combination between the series and parallel. Okay, let's take a inside look at the motor. We just take a section so we can see the interior parts. There are fans here that allows the air to flow inside the motor, and there are a rotor which causes the rotation of the shaft. There are stator and some coils to generate the magnetic field. There is a driven end here connected to this using coupling. There another end here which is the non-driven end, so that the fixation and bolts can be fastened here. Turbines. Turbines are basically used to drive another component, such as most of the time is a compressor or pump. So let's take a look at the inside parts of the turbine. There are some turbines here. There are shafts, and this is the where the combustion chamber where the fluid and air is mixing. And there are compressor here, then a shaft which drive the another component. Now let's watch this video, which gives you a quite good illustration of the internal component of the turbine and how the turbine actually generates the work.
The inlet casing provides a smooth transition flow of air from the filters, through the silencers, and into the axial compressor. The inlet casing also provides access to the thrust bearing and the inlet journal bearing. Variable inlet guide vanes are located in the inlet casing directly in front of the first row of compressor blades. The vanes are used to regulate the amount of air entering the compressor. The circular operating ring actuates the guide vanes so that all vanes move in unison when opening or closing. Before each set of rotating blades is a set of stationary blades, or blade rings, that direct the air to the next set of rotating blades. The compressor blade rings have stationary airfoil-shaped vanes that direct the air to and from the rotating compressor blades. The rotating blades force the air into progressively smaller spaces as the air passes through the compressor. Heat of compression is generated in the air as it is passed through successive compressor stages. The compressor consists of 16 rows of individually removable rotating blades. Each blade is locked in place by a dovetail arrangement at the base of the blade. The rotor is made up of a bladed compressor spindle and a bladed turbine spindle that is bolted together to make one single shaft.
Okay, I'm quite sure that most of you know how the engine works based on the fact that you are senior students and most of you are about to graduate. So I'm just going to give you a brief illustration about this, how this engine works. This is a single cylinder and piston reciprocating engine. The gas mixture comes from outside and goes inside this room. When this mixture is compressed in the second phase, it causes an explosion. This explosion drives the cylinder to go down. When it goes down, the valve opens so that allowing the gas mixture to go outside. That leads to the piston to go up and again.
Assalamu alaikum. My name is Muhammad Khudari and I'm going to talk about the pumps. Pumps' function is to transfer the fluid from one point to another, for example from point A in here to point B by the pressure. Pumps are one of the driving components and it have many types. For example, we have centrifugal pump, axial flow, reciprocating pumps, rotary pump, screw pump, vertical pump, and positive displacement pump. Centrifugal pump is one of the most common pump in the industry. It uses the centrifugal force to move the fluid from one side to another. You can see in this picture here the component of the centrifugal pump. The fluids come into the pump by the suction nozzle and then go to the impeller, which use the centrifugal force to push the fluid to the discharge nozzle. The impeller is connected to the shaft of the motor, and the shaft is supported by the bearing. The following video will explain how rotary pumps works.
Rotary pumps are defined as being vane, piston, flexible member, lobe, gear circumferential piston, or screw pumps. In all of the rotary designs, the chamber is created progressively through rotation of the drive shaft. There may be one or more chambers open per revolution depending on the design. The chambers are sealed off from suction by close clearance between the rotor and the housing, or by close clearance between intermeshing rotors. Rotation of the shaft moves the chamber along the bore or housing towards discharge. The chamber is displaced to discharge by rotation. The release to discharge progresses with rotation, as the volume is expelled so that the flow is typically pulsation-free.
Reciprocating pumps will be explained in this video.
Reciprocating pumps are defined as being steam, power, or controlled volume pumps. In all reciprocating pumps, there are check valves on the suction and discharge. Fluid flows through the suction valve and into the chamber as the plunger, piston, or diaphragm recedes. At the end of the stroke, the chamber is at its maximum size. The suction valve closes, the plunger moves forward into the chamber, forcing the fluid out the discharge valve. The flow from each chamber is a pulse flow. If the pump has several chambers, they are timed to have sequential pulses, to minimize the overall pulsation.
Screw pump, also called Archimedes pump. It uses a very simple technique by rotating the screw in a cylindrical cavity. It moves the flow from a low point to a high point. Pump stages. Pumps can come in a single stage, which means it have only one impeller, or multi-stage, can come 2, 3, and so on number of impellers. As we can see in the picture here, we have 3-stage pump which have 3 impellers. There are 2 ways to support the impeller on the motor shaft. We have a center hung pump, and this is basically we put the impeller between 2 bearings, or the overhang pump, and from the name you can see the impeller is overhanging the shaft, and the bearing are in the middle.
Assalamu alaikum everyone, I'm over here to present the mechanical fans. So let's start with the mechanical fans. You see there are 3 types of mechanical fans: axial flow fans, centrifugal fans, and cross flow fans. Mechanical fans, what are they basically? Mechanical fan is a machine that is used to create within a fluid, typically a gas such as air. The fan consists of a rotating arrangement of vanes or blades which act on the fluid. The rotating assembly of the blades and the hub is known as impellers, a rotor, or a runner. Usually it is contained within some form of housing or a case. This you see is a axial fan. What is an axial flow fan? An axial flow fan have blades that force air to move parallel to the shaft above which the blades rotate. The axial fans blow air along the axis of fan linearly, hence their name. This type of fan is used in a wide variety of applications, ranging from small cooling fans for electronics to giant fans in wind tunnels. Axial flow fans are applied for air conditioning and industrial process and application. Standard airflow fans have diameters of 300 to 400 mm or 1800 to 2000 mm and work under pressure up to 800 pascals. This you see is a centrifugal fan. Now let's see what is a centrifugal fan. Centrifugal fan is often called a squirrel cage because of its similarity to exercise wheels for a pet rodent or a scroll fan. The centrifugal fan has a moving component called an impeller that consists of a central shaft about which a set of blades or ribs are positioned. Centrifugal fans blow air at right angles to the intake of the fan and spin the air outwards to the outlet by deflection and centrifugal force. The impeller rotates, causing air to enter the fan near the shaft and move perpendicularly from the shaft to the opening in the scroll-shaped fan casing. A centrifugal fan produces more pressure for a given air volume and is used where this is desirable, such as leaf blower, blow dryer, air mattress, inflators, inflatable structures, climate control, various industrial purposes. They are typically quieter than the comparable axial fan. This, my friends, is a cross-flow fan. The cross-flow or tangential fan, sometimes known as a tubular fan, is patented in 1893 by Paul Mortier and is used extensively in HVAC industry. The fan is usually in relation to the diameter, so the flow extremely remains two-dimensional and allows away from the ends. These fans, the CFF uses an impeller with forward curved blades placed in a housing consisting of a rear wall and vortex wall. Unlike radial machines, the main flow moves transversely across the impeller, passing the blades twice. So you can see and you can understand how the air movement is occurring in the cross-flow fans. Now, compressors. What are compressors? An air compressor is a device that converts power, usually from electric motor, a diesel engine, or a gasoline engine, into potential energy by forcing air into a smaller volume and thus increasing its pressure. The energy in the compressed air can be stored while the air remains pressurized. There are three types of compressors. One is a centrifugal compressors, the other one is reciprocating compressor, and the third one is a screw compressor. Is on the right, you see, is a centrifugal compressor. Now, what is a centrifugal compressor? A centrifugal compressor, sometimes termed as radial compressors, a subclass of dynamic axisymmetric work absorbing turbo machinery. The ideal compressive dynamic turbo machine achieves a pressure raised by adding kinetic energy velocity to a continuous flow of fluid through the rotor or impeller. This kinetic energy is then converted to an increase in potential energy static pressure by slowing the flow through a diffuser. The pressure rise in the impeller is in most cases almost equal to the rise in the diffuser section. Now we come to the reciprocating compressors. You can see a reciprocating compressor, and they're also known as the piston compressor because they have the piston system inside them. A reciprocating compressor or a piston compressor is a positive displacement compressor that uses piston driven by a crankshaft to deliver gases at very high pressure. The intake gas enters the suction manifold and then flows into the compression of the cylinder, where it gets compressed by a piston driven by reciprocating motion by a crankshaft and is then discharged. Applications include oil refineries, gas pipelines, chemical plants, natural gas processing plants, and refrigeration plants. One specialty application is the blowing of plastic bottles made of polyethylene terephthalate, which is commonly known as PET. Then we come to the compressors, screw compressors. You can see a screw compressors, and it consists of helical or a worm type screw. It looks like a screw and also like a worm type gear. Now, what it is actually? A screw compressor, or also known as a rotatory compressor, is a type of gas compressor which uses a rotatory type positive displacement mechanism. They are commonly used to replace piston compressors where large volumes of high pressure air is needed, either for large industrial applications or to operate high power air tools such as jackhammers. Gas compressing process is a rotatory screw is continuous sweeping motion, so there's very little pulsation or surging of flow as occurs within the piston compressors. Okay, my friends, now I come to the last part of my presentation, which is the gearbox. Now we know from Menge 410 what is a gearbox. A gearbox is a device where there is a combination of gears which are used in order to reduce the speed. Now if you see over here is a gearbox, and there's an input from electric motor which is directly connected to a worm gear, and then it transfers the rotation to helical gear, and then it through different steps it comes out through the output shaft. So this, you can understand, all of them are locked inside a box, therefore you call it a gearbox containing a lot of gears inside it, with the purpose of increasing or decreasing the rotatory speed. The output is also in rotation, but it could be in a very different direction at different speed, higher or lower RPM compared to the input RPM. And thank you. The rest will be presented by my other friends. Assalamu alaikum.
Assalamu alaikum, I'm Ahmed Harbi. I'm gonna talk about the couplings. Couplings are used to connect sections of shafts or connect the shaft of a driving machine to the shaft of a driven machine. For example, in this mechanical system, we have the driving machine, which is the motor, and the driving machine, which is a saw drive, the output of this mechanical system. And in between, we have the intermediate components, the driving components, the intermediate component, and the driven component. In the intermediate component, we have the drive belt, the belt drive, and the gearbox, and the coupling. And here I'm gonna talk about the coupling. We have two kinds of couplings. One is the rigid and flexible. Rigid couplings are used for low rotational speed and for accurately aligned shafts. An example of the rigid couplings, the most common used is the flange coupling and the clamp coupling. The other kind of couplings is the flexible couplings. It's used to transmit torque smoothly, and it permits some axial, radial, and angular misalignment, and also it alleviates shock by providing transfer of power through springs, or to absorb some of the vibration in the coupling using flexible elements. Here are some examples of the flexible elements. We have the flag coupling and the roller chain coupling, which consists of chains, and the universal coupling. This one is the most commonly used. Also, we have the Oldham coupling and the gear coupling and Paraflex coupling.
Assalamu alaikum everyone. My name is Mohammed Tirsan and I'll be commencing this presentation. So I'll be speaking today about bearings, which is quite interesting actually, because we have a couple of things that we're going to speak about. So bearings, the start. We have two kind of types of bearings we'll be speaking about today, which is the rolling element bearings. So basically things like taper bearings, deep groove ball bearings, and general bearings, which have metal-to-metal contact. The rolling element bearings, like I previously said, we have two types. We have the tapered bearing, as you can see over here. We have the deep groove ball bearing over here. We have many famous companies that manufacture this. For instance, the known one would be FAG and SKF, the Swedish company. The advantage of a deep groove ball bearing is basically it's a good trade-off between cost, size, weight, carrying capacity, durability, accuracy, and friction. Okay, what does this all mean? It means that it's standardized in an economical way. So you can basically buy it in a cheap way. So the journal sleeve bearing is basically not like the previous. So we basically have two parts. We have the journal over here, and here's where the metal to metal contacts will occur. The advantage of a sleeve bearing is basically it can handle high loading velocities because of the metal to metal contact is minimum due to oil film. Because as you can see previously, there is some space where we can put oil to avoid metal to metal contact. See here from the journal bearing that we have an oil film over here, as you can see. So this reduces the metal to metal contact, and this will help a lot in the velocity. So we have also important aspect that we have to put in consideration as well, which is the lubrication of bearings. So there's three types of, like one of the types of lubrication for a rolling element bearing would be oil lubrication, as you can see. Here's the oil pump, oil mist lubrication, and grease lubrication. As for the rolling element bearing, as for the journal bearing, we have this kind of lubrication. We have the sump lubrication, oil ring lubrication, and pressure-fed lubrication systems.